FastMCP2's asynchronous task monitoring system employs a non-blocking status checking mechanism to provide real-time progress updates without interrupting concurrent operations. This pattern leverages the status method to retrieve a structured status object containing both state enumeration and descriptive messaging. We're about to examine how this status checking pattern initializes by awaiting the task's current state and formatting the output to display both the status code and its associated message. The implementation will demonstrate the 4 possible states while maintaining clean separation between status retrieval and presentation logic.
Status equals await task status. Print of a status status message. Hash status is working, completed, failed, or canceled.
This code demonstrates non-blocking task status monitoring in FastMCP2, a pattern that enables concurrent operation tracking without halting execution flow. The status method provides an asynchronous way to check a task's current state, returning a status object with both a machine-readable status field and a human-readable status message. This approach allows developers to poll task progress while continuing other work, a common requirement in long-running operation scenarios. The design uses 4 distinct states, working, completed, failed, and canceled, to model the complete lifecycle of background tasks. This state machine pattern provides clear transitions between operational phases, enabling precise status tracking. The separation of status code and message follows the Unix convention of exit codes with descriptive text, balancing machine processing with human debugging needs. This pattern is particularly valuable in distributed systems where operations may take unpredictable durations, allowing for responsive UIs or efficient resource utilization while waiting for completion. Let's break it down line by line.
Status equals await task status.
Asynchronously retrieves the current status of the task object by calling its status method and assigns the returned value to the variable status. The await keyword indicates this is an asynchronous operation that will pause execution until the task's status is available.
Print of a status message.
Prints a formatted string combining the status property and status message property of the status object, separated by a colon and space. The output will display the status code followed by its corresponding message, such as 200, OK, or 404, not found. FastMCP2's asynchronous task monitoring pattern combines non-blocking status retrieval with clear state modeling to enable responsive progress tracking. The await task status call asynchronously fetches the current state without halting execution, while the return status object cleanly separates machine-readable codes from human-readable messages. This design mirrors Unix conventions, balancing automation needs with debugging clarity. The 4-state model, working, completed, failed, and canceled, provides a complete lifecycle representation, allowing precise tracking of background operations. By decoupling status retrieval from presentation, the pattern maintains clean separation of concerns while supporting concurrent operation monitoring. The approach is particularly effective for long-running tasks in distributed systems, where unpredictable durations demand both responsive UIs and efficient resource utilization.
The task that checks its status finds it was completed before the first line of code was written.